Hello everyone to this new session of the Qt World Summit 2021. Before jumping into the presentation, I just wanted to remind you that I will be answering your questions on the chat, and also if you want to join to the speakers launch after the talk, I will be there in case you want to follow up on some topics. So let's dive into the talk. The title is Hybrid Qt Development, Boosting Your Projects with Python. I expect here in this presentation that you will fit one of these two profiles. The first profile is C++ developers are a little bit aware of the Python offering and will be willing to know more about the Qt for Python project. And the other side of the audience, I expect that you are familiarized with Qt for Python, maybe PySide, and you are willing to know more what's going on with the project. So, before jumping straight into the examples and everything, I just want to give a brief introduction and motivation of why we are doing this thing. I mean, this year is, I think, the fourth year that we have a talk related to Qt for Python on the Qt World Summit. So Python as a language and Qt as a framework are roughly the same age. The development of these two nice tools that we currently use started around the same date, and also the releases were roughly around the same period, maybe some plus minus some years there. But the point that I want to do this thing is that besides the maturity of both the programming language and the framework, both Qt and Python have the one common goal in mind, which is simplicity. If you maybe are familiarized with the previous talk that we gave with the Qt for Python projects, I gave a talk in 2018 when I was highlighting a couple of insights from the Stack Overflow survey, while positioning Python as the 7th most popular, 3rd most loved, 1st most wanted, and the TOB index also was the 4th place. And later on, I gave a webinar in 2019, and you can see there how the places started to improve for Python. It was still the most wanted, but the other ones were kind of going up and up. And if we look at the current scenario, we can see that this year's update, we can see a few patterns here. So most popular is still growing, now is in 3rd place. Most loved, yeah, I understand that there are many other languages out there that people kind of like are more into it, so we are looking for, but still is the most wanted language, and also it reached the 1st place in the TOB index after 20 years. So as I said here, one can argue those numbers are really not representative, but the message that I wanted to give you is that we can really neglect the whole impact that Python has in fields like data science, data analysis, data engineering, and artificial intelligence in general. Also considering that the community around the Python language, it's quite rich, and we can see it is reflected into the many organizations in different countries, cities, organized by topics. We have the PyCon, we have PyData, we have a whole new ecosystem of online Python editing, like Jupyter, for example. So there is a lot of things going on there. So maybe now you're wondering, okay, but this is a Python talk? Well, not really. The thing is that we cannot talk about Python popularities without talking about C++. And the reason I'm saying this is because most of the popular modules that are out there, they really rely on something like C++ underneath. So there is a couple of examples here that NumPy, for example, has a lot of things with C, Fortran, Pandas, C purely, and both TensorFlow and PyTorch, if you are more into machine learning, rely on a backend of some library written in C++. So we can even claim that with Qt for Python, we are trying to be one of the elements that mix these two languages we love, C++ and Python, and of course there are many other things going on here in the middle, but this is something that is enabling Qt as a project, as an ecosystem, as a community, to reach a different type of audience. We are now expanding our well-known C++ community, and we are going to a different language. So you might know about Python, the Qt for Python, that is the official set of Python bindings. And this is something that I would like to maybe emphasize a little bit with a couple of examples that even though this is the official definition of the projects, it's not really that. So I just want to maybe highlight now a couple of things that maybe you didn't know, or maybe you are aware of it, but I just wanted to share to you that just to break this misconception that, okay, so the Qt for Python is only the bindings for the Qt project and that's it. I mean, if I just want to continue in C++, that's it. I don't care anymore. And that's another language, end of the story. The Qt for Python project is really aiming to go one step forward and try to offer both Python users and C++ users a different set of tools and mechanisms that we can continue to push the integration of these two fantastic languages and communities. So the first aspect that you might not be familiar with is that with the Qt Python project, we are enabling the whole spectrum of Python modules into Qt applications. As you can see here, I will just play this again. This is, for example, image filter processing from the scikit image module. So we are getting different properties of this system, but maybe the implications can be more simpler for you to grasp with this, for example. You can say, okay, that's Qt charts, but it's not. It's one of the most popular and old plotting modules of Python, which is called matplotlib. As you know, many tools out there have different backends in different UI libraries. The case of matplotlib, it has a GTK, for example, or other default things, but also has Qt. And having Qt as a backend enable us to do these things. You can see here there's a matplotlib canvas that is interacting with a Qt widget representing the data of the different type of plots that we are showing, and also we are controlling this by some widget controls that you can see down there. So that's one aspect of it. The other thing that we were trying to do in the Qt for Python project is that we want to enable more features. The process of the Qt development in C++ is really well established, is really something quite mature, and that's why Qt is currently the leading framework out there for creating user interfaces and other type of programs, because everything has their own schedule and program. So with the Qt for Python projects, we wanted to have a little bit more freedom in a sense, and try to bring to the table like many new ideas that could help Python users to get more familiarized with the Qt ecosystem, and maybe also convince a couple of C++ developers to try things in the Qt for Python projects. So the first one that we are doing maybe might sound a little bit silly for you if you are really a hardcore C++ developer, or maybe a Java developer with some background in Java, but it's something that is really making the difference in the Python ecosystem. The number one complaint that I always had every time that I was going to a Python event was that the whole Qt API is camel case. And as you maybe know, or maybe you didn't know, in Python usually the APIs are snake case, meaning that there's no capital letters after different words, but they are putting together with using an underscore. So the first thing that we try to do is to introduce a new feature option. As you can see here, once you enable the snake case, you then automatically convert all the Qt API, not the class names, but the methods of each class, into snake case. You can see here we go into set column count, into this with the different names, the same with other methods like set enable, add widgets, and so on and so forth. And believe it or not, I mean, even if it is just like maybe you are saying like, oh, okay, but this is silly, I mean, who cares? Well, imagine that you need to change to a different case in the APIs that you are working with. It will be kind of complicated. Maybe your muscle memory is kind of used to work with it and even design new API based on camel case. And besides this, as you can see here, the comment as a spoiler, we rely the Qt framework and classes and stuff in setters and getters. It's kind of like the one of the foundation aspects of the Qt, right? It's really easy to understand. Well, but in Python, it's not really like that. In Python, usually one accesses directly the properties. So you can see here that now if you import true properties, you really don't need to rely on all these setters and getters, and you can get directly things like the property column count and change the value. The same with the enabled property, spacing, and so on and so forth. So again, I mean, this might sound like okay, whatever, but it's something that is really, really important for everything that is really used to develop Python programs. And also, as I mentioned before, it's something that people really were asking for really, really often. So you can enjoy all these features from Qt 6.0 onwards. Another thing that is quite interesting is that every time that we were working with Python containers, like you have a Python list, a dictionary, whatever, and you want to pass this to a method that receives that, but maybe under the hood, it's maybe a QList, a QVector, or QHashMap, this kind of structures. The process that we were doing was to copy the whole Python container into a C++ container, then passing the C++ container to the function. And bad luck for you if for some reason that method was still returning a similar container, because then we will need to form the Python container and expose it back. This is really bad in terms of when you are doing using heavily many functions that are interacting with containers quite often, like say, like for example, drawing on the screen different points and updating them quite often. This can be really a bottleneck for the performance of your Python application. So that's why there was this nice idea inspired by other binding generator tools to create some kind of opaque container that will be a direct wrap into the C++ object that is underneath the Python objects. Also to implement the sequence protocol. So this means that you will be able to access as a sequence in Python land, and also to provide a couple of methods to interact with the items there, maybe adding or removing items. So what you can see here is that initially, just to testing, we decided to expose a couple of list-based options. So instead of having a Python list of, there's a typo here, but it's a list of QPoints or another element with QPoints, we expose a QPoint list within an opaque container. So I did a really simple and silly example. I just had, okay, I will grab 1 million numbers, I will create 1 million QPoints, and then I will just add them and read them. So the results that you can see here from the opaque container, it's roughly less than a second, half a second. With a Python list, it's, well, a little bit more. And DQ, which is a Python extractor specifically for working for queues, of course, DQs, we get that the opaque container is around 50% faster. If we are doing a really expensive operations and lists in Python list, which is popping the first element, we get this awful speed up from the Python side of things. So, okay, this kind of, this might sound like a bit silly, that it's not really something real, or Python users will not rely on this. But as I was mentioning before, the queue extractor is mainly optimized for working on these things. And even in that scenario, just for reading and getting for popping the first element of this extractor, we get still like 300 speed up of these things. I know, I mean, these things also implies that we are transforming things around, but even if this kind of sounds like a silly example or maybe extreme case, it's not impossible. Imagine that if you are plotting something on the screen and you are refreshing this every second, and you are reliant on flooding a different set of numbers, and you are popping the first one, like maybe a function, a sign function that is passing by, you will encounter these issues with the speed up there. As I said, if you forgot that this is a typo here, this should be a Q point. Another thing that is quite interesting is that as C++ users, you might know, okay, so we compile our programs, we deploy our programs, and that's it, end of story. Well, Python users have many different options. So the first option is that, okay, you pass your Python script and you give it to whatever person is trying to use it. But also there are different tools that they try to freeze your Python applications. In a nutshell, if you're not familiarized with freezing a Python applications, this roughly can be translated into making a zip of the serialized code that then later on it becomes an executable that every time you execute or double click, whatever, it kind of unzip the whole thing, execute the code, and then remove the content of the program that you do. But besides these freezing applications, there are other projects that they are trying to do something different. We can see here at the end, the Nuitka project. They try to really compile Python code because, as you might know, the usual vanilla Python, it's Python that is written in C with the C Python. So this project is quite interesting, and we are really happy to say that we are compatible both in Qt 5 and Qt 6. And for the other tools, also many people has been mentioning a couple of issues that sometimes we face with stuff that is not in this side of the fence, but we need to kind of go there, maybe try to contribute some helping us out. But at least we have been discussing with many users and some maintainers of these packages to deploy your application. So even if the deploying aspects of Python project is complicated, with Qt for Python you will have a good experience in the sense of that it is possible to do so. Many people has been asking around, like, what do you have maybe your own tool to deploy? We are still a little bit hesitant about creating yet another tool. Maybe you're already familiarized with this XKCD comic about standards, but there are many options out there of big teams doing a lot of work to make this thing work. So we feel like reinventing the wheel for those things will be a little bit counterproductive to this thing. So at the moment we are relying on contributing back to these projects and see what is going on there. At some point, of course, we might get the case that we really need our ad hoc deployment tool to maybe combine Python and C++, and maybe in that scenario we can do something about it. Another thing, I was just mentioning Python vanilla, and this of course is a reference of the CPython implementation. There are many other Python implementations out there. Maybe you're familiar with Rust Python, for example, in Rust, IronPython in C#, and so on and so forth. There is one that's called PyPy that is a Python implementation written in Python. One of the good things about it is they claim that using it on top of your script can get an average at 4 point something speed up on top of the current implementation. So there are many use cases out there when people is relying on getting this little bit improvement for the code that they are executing. So they try to use other tools. And since PyPy will work out of the box without any other change, it's a really popular Python implementation. One can argue, okay, why you maybe didn't do anything else to maybe to be more compatible with Python, or I don't know, with Rust Python since Rust is so popular. Well, the main issue is that you can, if you execute your application like Python application with PyPy, you can do the same, and there are no many other changes going on there. Many other Python implementations are not really complete and rely on really maybe old versions, so that we are keeping an eye. There are many other new Python implementations out there. There's one called Piston, another one Pigeon. So we want to be as compatible as possible because people might be keen into using other interpreters. And now we are going into more like a C++-ish section of the talk. I know we have roughly 10 minutes still to go, but let's try to highlight a couple of examples of this. If you are not familiarized with Shiboken is the binding generator tool that we use to create PySite. In a nutshell, this tool kind of reads all the Qt headers information. We do define some stuff on a type system, which is nothing else than like XML file. Then Shiboken managed to generate some wrappers based on CPython that will call Qt API. And then after that, we can compile this CPython compatible code and create the PySite packages. Okay, so what you can see here is that if we kind of remove the Qt logo from it, we are reading headers of a C++ library and generating a Python module. So yeah, You are right if you were thinking about this thing, that with this you can easily expose C++ code to Python. The most simple example that you can see is like, let's consider a really simple file that's called test cpp that generates a function that is called hello, that just print a message. That's it. You will require a capital file. So besides your super duper library there, you will require main header files. In this case, it's only including the test HPP, but if you have more, then we'll include the other ones. And then you'll require the bindings XML file, that it's nothing else than this XML that I mentioned beforehand when you say, okay, I will create a package simple, and inside there's a function hello. So here you can see a quick example. We have there the test CPP, and also we have there the main. So we want to execute this from Python. After we build the project, we need, of course, some CMake magic there. After that, we will just copy the shared library into the directory that is executing the Python code. You can see it there, simple.so, and this shared library will be enable us to import it from Python, and you can see the message there, hello Python from C++. So this might sound simple and silly, but imagine that the possibilities you will have to expose any C++ module that you are using into a Python module. You will say, why do I want that? Well, if you are working on a company that has different teams, it's highly probable that you will have people relying on Python scripting for some maybe automation of tasks, maybe some artificial intelligence, and you can enable those things by creating this new API for Python users, and why not become one of the most popular Python modules for next year or something like that. So there are many C++ libraries that are really cool that does not exist in Python, so there's still a chance for you to make a difference in this other community. Another thing, and quite common uses for this, is that, but I have my custom widget written in C++ and I don't want to rewrite the whole thing in Python. Well, still following a similar approach, you can rely on having your own C++ widget exposed to Python via Shiboken. Of course, here we are getting use of the things that we provide with PySide, which is the whole widgets transformations and rule for the Qt widgets modules, as I said. So you can load those things and using it. This is a widely known example, the Wiggly widget. So you can find here that on the top, the C++ exposed to Python is running, and on the bottom, there is a pure transformation of the code to Python working there. So in a nutshell, this is kind of what is happening in the Python code. You can see same results. This is a really interesting example. I'm here executing a Qt C++ application. You can see there are some Python code there, and if I type run, I am running Python code from these C++ applications. There are many status there. There was an empty column there, and I will copy a couple of plugins into these directories. So if you see inside, there are only 2 Python scripts. Let's open the one that is related to the app size. You can see there is a function there. We are importing some model from Python, adding some actions, zoom in, zoom out, and doing some stuff with the main windows. So since we move these things, now you can see there on the left that there are these 2 Python files, are 2 plugins, and now you have the option to create these new items in the menu that create a zoom in and also even a dark mode for your thing. This is the most common usage that we see out there for C++ users, extending your current application and enabling a plugin system based on Python. And if you are using, of course, Qt and C++, why not using Qt for Python right away? Because this will be, of course, really for you easy for you to get familiarized and to integrate in your tools. As I said, this is the most common use case. There are many customers out there of Qt that are using this. I also know a couple of open source projects that also are relying to a similar approach. Though this is really something that you can give it a try. So the whole generation of this, it's with Shiboken and everything, we noticed that it was kind of a little bit complicated if you are really not familiarized of how PySide works and how Qt or CMake work. So for this, we decided to create a small tool for commercial users that is mainly a graphical helper of you to create your own binding generation process in a more easier way. So what you can see here is an interface that allows you to point to the proper C++ implementation and that library you have, select a couple of options, specified headers, and this will automatically generate for you the CMake file for exposing your module to Python. We released this some time ago. We are really looking forward to get some feedback, and if you're curious on all the details on how to see these things in usage, check it out. I mean, I will share this slide later on, but these videos are all in doc.qt.io/qt for Python. You can see there the specific videos version, so you can check them out with the detail. This is something that we have been playing around a little bit. So it's a proof of concepts. Don't get scared or don't get too excited. We are just testing waters with this. QtScript with a Y. It's inspired by QtScript. Maybe you remember it. Something that was enabled to run some Ecmax script in there. It's not a port. It's just inspired. We found many use cases where C++ users wanted to execute Python code within the C++ applications, but maybe not with the whole fancy plugin system or graphical way. So we decided to play around with it, and this will, in summary, enable you to run Python code inside your C++ application, but also interacting with the return results. You can see here on the right that after we declare a simple engine, we will be able to execute some code, meaning that there is no returned results. You can also evaluate code that you can get something back. You can also load a Python module, which is nothing else like a file, declare some functions from that module, and use the functions directly. But let's look at this at a more clear example. Here, execute no returning, so I'm doing inside a print of list comprehension using the power to the 3. You can see this will be the output there, all the power of 3 of the numbers. You can do, and maybe you use a string method for Python, which is the title one, that you can capitalize the first letter of each word. You will get something like this. You can also evaluate and calling some functions there. You have a sum of the first 100 elements, then you get the results. As you see here, we are relying, of course, on qvariant, which is something that internally we transform always to Python types. And here you can see a silly example that has a Python file called super.py that inside has a function called add 3 numbers that receives 3 arguments. So we are declaring this. We declare our arguments with a qvariant list, and we pass this to arguments, and you will get after this, of course, the results of that thing. So as I said, this is a proof of concept. We are still playing around with it. Let us know if you believe that this is a really good idea. If you think that this is a really bad idea, also let us know. Why not? But we are also trying to look into more ways of making C++ and Python play well together. What are we currently working on? We are mainly trying to improve the compatibility in the Python ecosystem. We are always listening to people using different Python models, and they have some caveats with using PySite. We're always trying to prioritize those bugs and the communication between the community, because we want to be the middle point between the C++ and the Python community. As you also previously saw, we are also working towards the PyPy support, and this is will be done soon. Besides that, Python relies on different tools that you can add some type hints on it, the code. This is not compiling it, but just to check if your code is properly behaving with the type of different variables. There are tools, one for example called MyPy, that relies on different type hints files that we are trying to work on it. Besides the whole opaque container stories, we are also finding a way of automatically transform Python containers into C++ container. This is something that currently we don't do automatically. We need to rely on a snippets that you can say how you will transform this qvector into a Python list, for example. So it's only for you. Something that might be a really good news for many people here is that we are working towards enabling Python to be easily cross-compilable. This is something that we have been struggling for a long time, but there are many nice things in progress that we are really looking forward to let you know about it. But No spoilers so far. And last but not least, we are working towards see how we can improve our experience of installing PySite modules. At the moment, we have one wheel with PySite and all the bindings inside, but we are thinking of options to try to distribute this a little bit. If you have more questions, these are the main resources, landing page of the product, the wiki page of the community, and the official documentation with videos, tutorials, guides, examples, and everything. Everything you will it will be in doc.io, Qt from Python. Just a couple of things before we finish. The community is quite active in different platforms. Just to highlight a couple of them, so we have a nice Telegram group, we have an IRC channel on the chat, and also is Bridge to Matrix from the KDE instance that you can visit there. The mailing list, if you have any questions and if you want to try other platform, check the wiki that we have in Qt for Python, which is the same as pysite.org. So that will be it now. We use around 31 minutes. I know it's not enough time. I will love to have maybe dive into the examples, but that's the slot that we got. So now I will invite you to maybe to ask some questions on the chat, maybe later on the speaker launch, or if you don't want to do it right now and you want to later jump into the community channels, please do. The community is quite nice and we are there just to answer your questions. Thank you very much.